Hello and welcome to this third tutorial in linear algebra. We're looking at how to rotate a point around the y-axis by transforming the point's x and z coordinate values. So in the land of linear algebra as viewed via OpenGL graphics, we're now looking directly downwards along the y-axis, but as explained in the previous tutorial, Blender's y-axis is our z-axis and its z-axis is our y-axis, and the positive and negative are reversed. The sine and cosine relationships are being used in exactly the same manner as for the z and x-axis rotations as demonstrated in the first two tutorials. Notice that the sine term for this forwards component has been negated in order to produce the correct z value, just like it was negated to produce the correct y value in the previous tutorial. More significant for this tutorial is that we're now comparing how the geometry looks different depending on whether we're applying anticlockwise rotation by using a positive rotation angle or clockwise rotation by using a negative rotation angle. Notice that by rotating the point in the clockwise direction instead of anticlockwise, so that's from here to here instead of from here to here, this vector becomes exactly mirrored by the z-axis and this vector is exactly mirrored by the x-axis. The only difference in the calculations is this value being positive instead of negative, and also this value being positive instead of negative. For the vector representations on the left, for the anticlockwise example, we have these two forwards components partially cancelling out, and these two horizontal components adding together. For the clockwise direction, we have these two horizontal components partially cancelling out, and these two forwards components adding together. Finally, I'm using the same test program as I used in the first two tutorials, which simply requires updating the vertex coordinates to this blue vertex, changing the rotation axis, and negating the sine and cosine terms accordingly. In the next tutorial, we'll be looking at how to combine the x, y and z axes together, and then in the tutorial after that, we'll be looking at how to represent these rotation transformations with matrices. Please don't forget to subscribe if you'd like to see more. Ta-ta for now.